It is a race against time, an intense rescue effort underway in Somerset County to get to 9 miners trapped more than 200 feet below ground.
They got trapped about 1.5 miles into a shaft in the Quecreek Mine.
Details are sketchy, but rescue crews are headed to the mine right now, and we've been told there's some kind of collapse, possibly flooding inside that mine.
They couldn't walk out the front. We knew that. The only other way they could come out is if you drilled a shaft down to them.
But we also knew that we couldn't punch that hole through until we had the water down to a certain elevation.
When the bit broke, we were really in agony at that point.
The top person's job, in this case the governor's job, is to ask the tough questions, to press the senior decision makers, to have them explain the how and the why, and sometimes to be real tough and pointed about it.
Well, I got my first call about 1:15 in the morning, a couple hours after the accident happened, and our deep mine safety folks explained to me that their best judgment was that the water was coming in to the mine at a certain spot where they thought the miners could run away from the water and get to higher ground.
We were guessing, certainly guessing where they were, but we believed that they would go to the highest elevation. Also, when you look at the contours of the coal seam itself, the one left section would rise in elevation from the beginning or the mouth of the section up to the working face where the crew cut into the abandoned Saxman mine. And with water flowing in from the abandoned mine, flowing down to the lower elevations, it was pretty reasonable that the miners would seek out the highest elevation in that section that they had available. And that's pretty much how we determined that the most likely place for the miners to be would be up in the working section. Once we determined where that location was underground on the map, then the decision was made to drill a hole from the surface.
You're dealing with very basic forces. You're dealing with rock, you're dealing with water, you're dealing with air. And there's only certain ways those three things interact on the ground. And it was the experience of our people and the knowledge of the situation that led them to take the steps of putting down that first 6-inch hole.
The actual location of where that hole was drilled was a result of the underground survey at the mine. Underground surveying is very similar to surface surveying, except on the surface you drive pins in the ground, underground you drive spads in the roof. And they had the known coordinates underground. So now they had to go out to the portal from where they surveyed the whole underground area from, and they had to go from that point on the surface overland to determine where the coordinates would be located on the surface to hit that point underground.
And fortunately, it was at a location that was suitable to get drilling equipment into, and that's how they determined where to drill that first hole.
The 6-inch hole that was drilled into an area where the rescue teams thought there might be a chance for the miners to be resulted in hitting air. Our Pennsylvania Mine Rescue Team reported that they did hear tapping.
The whole purpose of drilling that hole was to establish that conduit and establish communications. Well, when we punched that drill steel through and it actually penetrated into the mine opening, we immediately heard somebody tapping on the steel, so we knew somebody was down there alive.
About the same time, the people in the field realized that air was escaping around the drill steel. The annulus between the 5-inch diameter drill steel and the 6-inch diameter of the raw hole was allowing air to escape out of the mine. That's when it was decided the best thing to do is leave that drill steel in place and continuously feed compressed air into the mine.
The driller had told me that originally when I asked him that he could put 950 CFM of air down there at 350 psi. We also realized that as the water was rising in the mine, it was also compressing the air. Well, the only place that the air could go was either back into the old mine or up around the outside of that the drill stills. So we made a decision that we would go ahead and try to seal around those stills the best we could. And we put airbags down around that steel to try to keep all the air in the mine that we possibly could.
There was a consensus pretty much of everyone there that was involved in the command center that the air not only was providing some supply of fresh air, but there was some degree of heat that was coming because of the compressors run at a fairly high temperature, and even though it was a small amount of air, about 900 cubic feet per minute, there would be some value of the heat that was being supplied.
And that literally saved the miners' lives really the first time, getting that 6-inch hole in, getting that compressed air down to them because they knew they needed it, and they needed it quickly.
Right now we have a large rig on its way in, and it's going to drill a 36-inch borehole right alongside the 6 3/4, 5/8 that we already have drilled. We will insert steel pipe down as the drill goes and hope to hit the same dry void as we were in right now.
They couldn't walk out the front. We knew that. The only other way they could come out is if you drilled a shaft down to them. And the fastest way to give them a way out was to drill an appropriately sized hole, get that hole down to them as quick as you could get it down to them.
But we also knew that we couldn't punch that hole through until we had the water down to a certain elevation. If we would have tried to punch that hole through and let that air out that was creating that air pocket, the water would have displaced it and it would have drowned the individuals that were there.
We started out with a 30-inch diameter hole that we could operate the capsule in. The capsule was 21.5 inches in diameter. It was used at the Sunshine Mine back in the early 70s to rescue miners, and that technology's been around for many years. The use of the capsule was certainly the most logical thing that popped out as far as how to rescue the miners.
A large diameter hole is out of the norm. When I say a large diameter hole, I'm talking a hole over, say, roughly 16 inches. So this was a large diameter hole. It wasn't an everyday occurrence, but it was something that the drilling companies were very familiar with. We had 100 men doing what they do every day. There wasn't anything unusual about what they were doing. The only thing was the time element. They would have drilled a hole like this, it may have taken a few days. Here we didn't have a few days to doing it.
We are also in the process of drilling at least 2 additional holes in different parts of the mine in order to set pumps. And the idea being that we would pump additional water out of the mine at different locations to help relieve the pressure that may be coming in on the location where we think the trapped miners are.
After that first evening, that's when the emphasis shifted to pumping water. That we knew we had to pump a lot of water, and that's when the calls started going out all over the country, all over Pennsylvania to get pumps. Big diesel pumps were being brought in from different places.
We knew we had to pump out the water as fast as we possibly could because that water was coming in there at a very rapid rate. 50 million gallons ultimately came into the Quecreek Mine.
Sometime late this evening, we were able to determine that if we could get the water to an elevation of 1829, then we could bring the miners out a dry hole. And the decision was made that that was our primary plan. Although we were working on some alternate plans in case we weren't able to get the water pump down fast enough.
The first place we had to pump water was in the box cut, which was located right at the mine portal. The water in that portal probably got up to at the highest point sometime Thursday afternoon to around 1855. So that water was about 15 feet higher than where those individuals were, and they were in the dry.
That gave us access to the water with large diesel pumps. We ended up with 9 of those 425 horsepower diesel operated pumps, and each one of them could pump about 4,000 gallons a minute.
Every pump we could get our hands on was put down into that box cut to start pumping water. They had to lay discharge lines up over the bank and do a lot of manual labor to be able to do that.
It was late Thursday when we were able to get enough pumps in place that the water stopped rising. But at the same time, we realized that we wouldn't get the water down to the elevation of 1829 just with the pumps on the surface, because the water would recede back into the mine and we wouldn't be able to get the large diesel pumps underground.
So we would have to put some holes into the mine and down in that mains area in the lower part.
We drilled 6 holes over there. 4 of those holes were used for large dewatering pumps. They were 24-inch diameter holes, and we put 17-inch diameter dewatering pumps into those holes.
So we were literally pumping out of both ends of the mine at the same time. Ultimately, we were pumping somewhere around 32,000 gallons a minute at the peak out of that mine, and that's quite a bit of water.
Once we seen that we could pump the water down, once we seen we stopped the water and was actually dropping that water, then the decision was made that, hey, we're going to pump this water and we're going to pump it to a certain elevation before we punch through into the mine.
I think it only appropriate that I begin with my opportunity to spend an appreciable amount of time with the families. You can imagine their very emotional state, extremely concerned about what the future holds for their loved ones. As I was flying to Somerset County on Thursday, I knew in my gut, and I certainly felt it in deep ways when we walked into that volunteer fire company in the meeting hall, that it was a life and death situation, and every minute counted. When we walked in, there were probably 300-400 people in the room, 9 families, so you had numerous members of the family and extended family in the building, and the temperatures literally were high and the anxiety was high, and they were faces of angst, a hunger for information, I think a hunger for confidence, a hunger for bearing on the part of those who would oversee the rescue, that there was a sense of command about what could be done and that it could be fruitful. So the faces collectively depicted all of those emotions and interest. In that, that 4-hour stretch or so, and don't hold me to the specifics, we got down close to 100 feet. But then about 2 a.m. last night, we got stopped.
When the bit broke, we felt that, that was a setback.
It was probably the lowest moment for the families.
The first thing that happened is the drill stopped drilling. We weren't progressing anymore. Pulled out of the hole to see what it was, and there was nothing on the drill stem at all. The hammer, the stabilizer, everything was still down the hole. So they went back down into the hole. If you can imagine, it's 105 feet down, and threaded one pipe onto another pipe. And were successful in doing that, and brought the hammer out. That's when we realized we had a problem. When we lost the hammer, it wasn't a good thing. But when we retrieved the hammer and brought the hammer up, and there was no bit on the bottom of the hammer, at that point we knew that it was a more difficult fishing job than we wanted.
Really, that kind of problem was the reason why we started the second rescue shaft. We wanted to double our chances of getting that shaft down to those miners, because we were really in agony at that point, waiting for the drill crew to get that bit out.
And, you know, that went on for hours. So it was quite a trial of an emotional nature for the families, for the loved ones. We had no guarantees that we were going to succeed at fishing out the broken drill bit.
The part of the bit that was left down there that we would have been able to attach to was only about 10 inches high at the most. So you had a bit that weighed 1,500 pounds, and you were going to pick it up by only grabbing 10 inches of it. It wasn't going to be easy.
Sometimes you can go many, many hours, and other times you can latch on in the first hour and recover it.
Originally, I went down with a taper tap, which was a long funnel-shaped tap with threads on the outside that you can cut a thread into another object. When you go down into the hole where the air would be blown through the bit, you try to go into the center of that hole and tap a thread into it and then extract everything back up out of it. We tried that and for quite a while, and that wasn't working. Then an overshot was made at the site.
The first one they tried didn't work. They did some other work on another one, and finally I think they got one from Punxsutawney.
Thank God, because of the ingenuity and the stick-to-itiveness and the wily ways of the company up in Punxsutawney, we were able to fashion a device that helped us fish it out.
It's actually a little bit bigger than the top of the circumference of that diameter on that bit. Not the outside diameter, but there's a little part that sticks up on that bit. And what you try to do is slide that down over it and twist it and create a friction connection.
And eventually they got the bit out.
We will have to stop drilling when we get very close to the void. We will have to put the piece of equipment that we've called the airlock actually on top of the well, weld it in place, and then close that off so that the air pressure is maintained.
The airlock was a contingency.
And we were concerned that if we found ourselves in a situation where we had to drill the rescue hole into the air pocket, and the air pocket was pressurized above atmospheric pressure, well, then the air would escape out of that 30-inch hole.
The same as if you would prick a balloon with a pin, the air would escape out through the hole.
If you let that air out, it would have been displaced with water.
This airlock was approximately 30 feet long and 36 inches in diameter. It was just a long tube.
And it was designed and built there at the site.
If we had a positive pressure in the air pocket when we drilled into it, we would have installed the airlock directly on top of the surface casing, bolted it down.
Then we would have pumped air into this chamber on top and brought its pressure up to match the pressure that we had found in the mine. At that point, we would pull the drill pipe and the drill tools up out of the hole. We had a 3-foot plate there. We'd have slid the plate over the top of the hole, relieved the pressure in the column in the airlock itself. Once the pressure is relieved, we'd extracted the drill tools, which were 23 foot 9 inches in length, put the capsule into the airlock. We would have pumped the airlock full of air at this point again. Once it was pumped full of air and it equalized the pressure that was in the mine, we'd be able to remove the 3-foot plate. We would have dropped down into the mine. Miner would have entered the capsule. We would have brought him up into the chamber. Once he was in the chamber, we'd slide the 3-foot plate over the top of the hole. We'd have depressurized the chamber, allowed the man out, and we just reversed that process for 9 guys.
That would have slowed down the recovery process, but it was a plan that we developed and just in case we needed it, and thank goodness we didn't need it.
We have reached a critical phase, and how we apply ourselves now is quintessential to our success.
We developed a very specific plan of what we were going to do. We were going to stop short of breaking through. We were going to see where the water level was. If the water level wasn't where we were needed it to be, we're going to wait.
We were down to within 40 feet of drilling into the mine, and we still had not dropped the water level to the 1829 foot elevation. So we made the decision to stop the drilling and just sit and wait and watch the water go down.
There were a lot of concerns about breaking through, what we would find, what the air pressure would be. There were concerns about the medical condition of the people down there, were they hurt? And that's where the advice of the SMART team, the Special Medical Rescue Team, was instrumental in helping us plan step by step what would happen once the breakthrough was made, and that became a very invaluable tool later, because everyone knew what was going to happen once that capsule went down and when it came back out.
We were plotting every half hour what the water level was, and we could predict pretty close when we would get to the elevation of 1829.
Once we hit that 1829 elevation and we punched through into the mine with the big rescue hole, right away they took air pressure readings. And when we had zero pressure, we knew we were okay.
All 9 are alive.
When I saw the first miner come up on that capsule, and every 15 minutes another miner came up, I mean, the feeling of joy and satisfaction is something you can't explain.
Up until that point, the only thing we didn't have control of was their survival. Once we cut through, then it was totally in our control. But up until that point, it was up to them.
I think that when you look back on this, you have to really look at training and education, because you know, we do a lot of training, mine rescue contests, mine emergency response drills. You know, that all lends to this type of a situation. You know, you do this training in hopes that you'll never have to use it, but you have to be prepared if something happens. If you had to write a script, you probably wouldn't have wrote it any different. Everything had to go the way that it did, on the surface and underground, and I think we needed a lot of help from the good Lord to make that rescue happen.
When the process that we had designed paid off and we brought up all 9 miners, it was a tribute to American ingenuity and Pennsylvania stick-to-itiveness and a never give up attitude that permeated the effort and the atmosphere there. And all of that amounted to a soul-changing experience for me.
There were a lot of people out at the drill site. That was really only the tip of the iceberg in terms of not only DEP's response, but all the other state agencies. We had lots of other people backing us up, trying to locate pumps, putting up a special website that gave people information and sort of a basic description of what was happening, because there was a tremendous interest about this worldwide. And it was really amazing how everyone in the department pulled together to get us what we needed. So it was a real team effort by the whole department and really all state government to get this job done.
My feeling and my confidence that Americans, and particularly Pennsylvanians, are capable of great feats that some would say were not possible, like bringing up 9 miners from 240 feet below the surface of the earth. I have supreme confidence that when we're brought to a challenge, we'll rise to the occasion and prevail. So if anything, it's my confidence and my optimism about the good nature and spirits of Pennsylvanians has been buoyed. But I came into this job as an optimist, and I'm departing as a supreme optimist because of what happened last summer.